Every Fortune 500 company in the world right now can tell you the exact location of, like, a $2 screw in their supply chain.
Well, absolutely. Down to the millimeter.
Right. I mean,
Oh.
you open up an ERP dashboard, and you can literally track that screw from a factory in Shenzhen straight to a warehouse in Ohio.
Yep.
But if you ask that exact same company how their best, most experienced engineer actually installs that screw into a turbine,
They have absolutely no idea.
exactly, zero idea. Like how much pressure they apply or the slight angle of the wrist or how they know just by the sound that the threading is catching properly. And it's a total blind spot.
It really is. The modern enterprise is essentially blind to its own physical reality.
Wow. Yeah.
Because, I mean, we've spent the last 50 years building systems of record for everything that can be neatly categorized, right?
Right. Like we have CRM software for customer interactions.
Exactly. And CAD or PLM software for product blueprints, financial software tracking every single cent.
But the actual work itself.
Right. The operational competence of the workforce, the actual physical execution of complex tasks, it remains entirely unmapped.
And that blind spot is exactly what we're exploring today. So welcome to the Deep Dive.
Thrilled to be here and unpack this.
So today's mission for you listening is to decode this fascinating new white paper and press release from EON AI Ventures. This just dropped, dated June 10th, 2026.
Yeah, it's a big one.
It really is. They're introducing a completely brand new category of enterprise software called Work Intelligence, or WI.
Right.
And the argument they're making here is that this isn't just, a new software tool. It's the missing system of record for how the physical world actually operates.
Which is huge for anyone listening who works in an industry where physical execution really matters.
Manufacturing, energy, logistics, healthcare, all of that.
Exactly. This is really about capturing the undocumented genius of your absolute best people.
Okay, let's unpack this with a bit of an analogy, because we have systems that track every single ingredient in a bakery, right? And every customer who buys a cake. But until now, we haven't had a system that captures the exact feeling of how the master baker kneads the dough. And that's essentially what Work Intelligence is trying to do.
That's a great way to put it. And if we connect this to the bigger picture, why is this technology so necessary right now?
Yeah, the timing here isn't random.
No, not at all. EON points to this massive macroeconomic crisis that people are calling the Great Crew Change.
The Great Crew Change. Okay.
Right. So if you look at heavy industry manufacturing, utilities, roughly 25% of the workforce is aged 55 and older.
Wait, really? 1 in 4 workers?
1 in 4. These are the veterans who, they don't even need the manual anymore.
Yeah, they know the weird idiosyncratic behaviors of a specific refinery.
Exactly. Or how to coax some legacy machine back to life when the official documentation is completely useless. And the problem is they are retiring at an unprecedented rate.
They're literally walking out the door and taking decades of this undocumented expertise with them. In fact, looking at the World Economic Forum's Future of Jobs 2025 report, which EON cites heavily in this paper, 63% of employers identify the skills gap as the #1 barrier to their business transformation.
It's incredible because you can invest billions in next-generation hardware.
Right?
But if the only person who actually knows how to optimize it is, playing golf in Florida, your massive capital expenditure is essentially stranded.
Stranded capital. Wow. So the financial implications here are just staggering.
Well, massive. Because historically, enterprise value was built on tangible assets, factories, real estate, physical inventory.
Right. Things you could touch.
But today, roughly 90% of a corporation's value is intangible.
Wow. 90%.
Yeah, it's their intellectual property, their brand, and importantly, the embedded capabilities of their people.
But the deepest, most vital slice of that capability lives in people's hands, not in manuals.
Exactly. It's what the philosopher Michael Polanyi called tacit knowledge. He famously noted that we know more than we can tell. Tacit knowledge. So it's the difference between explicit knowledge and, physical instinct.
Precisely. Explicit knowledge is the manual that says, turn the valve 90 degrees.
Right.
But tacit knowledge is the subconscious realization that because the pipe is cold today, the metal has contracted.
Oh, wow.
So you need to apply a slightly different torque, and you stop turning when you feel a very specific vibration in the handle.
You literally cannot write that down in a standard operating procedure.
You really can't. And this highlights a fundamental limitation of all our current tech solutions. We've relied so heavily on text-based systems to transfer knowledge.
Right.
But tacit knowledge just cannot be flattened into a two-dimensional text document. It's spatial, it's environmental, it's physical.
Okay, let me play devil's advocate here for a second. Because, wait, we keep hearing how incredibly smart AI is today.
Sure.
I mean, if we have large language models right now that can pass the bar exam or diagnose rare medical conditions, why can't you just point an advanced LLM at a factory floor and have it figure out how to unstick a valve? Well, because an LLM is basically just a sophisticated prediction engine trained on the structure of language.
Right.
It understands the statistical relationship between the word torque and the word valve, but it has zero comprehension of the actual physics, the geometry, or the material constraints of those objects in three-dimensional space.
Oh, so it just knows the words.
Exactly. If you point a generic AI at a physical task using a camera, it just generates words about the image. It'll say, a worker is standing next to a machine.
But it doesn't know what they're actually doing.
Right. It cannot comprehend the sheer force being applied or the spatial trajectory of the worker's hands. It knows the vocabulary of the work, but it's completely ignorant of the reality of the work.
Okay, so it's like someone who has memorized every single Wikipedia article ever written about swimming, but they've never actually been submerged in water.
That's a perfect analogy.
Like, they can ace a written test on the mechanics of the butterfly stroke, but the second you push them into the deep end of a real pool, they drown because they don't understand buoyancy.
Exactly. And that is the precise barrier that EON is breaking through here. Their thesis is that to capture physical work, you have to move from words to worlds.
Worlds, not words. I like that.
Right, because you just cannot use text to capture spatial reality. Now, EON has spent 25 years in the immersive learning and extended reality space.
Oh, so they have the pedigree for this.
They do. And they argue that work intelligence requires a closed-loop system made up of 4 simultaneous converging breakthroughs.
Okay, let's get into the mechanics of how this loop actually operates on the floor. Because, saying you're going to digitize human instinct is a really great marketing pitch.
Oh, for sure.
But engineering a system to actually map spatial reality is an entirely different problem. So they start with a process they call Genesis, right?
Yes. Genesis is the automated authoring of the digital twin.
Okay.
Because in the past, creating a 3D model of, say, an oil rig took months of manual CAD programming.
Yes, painstakingly drawn every pipe.
Exactly. But Genesis uses AI to parse existing data engineering diagrams, LiDAR scans, existing CAD files, and automatically builds an intelligent 3D spatial twin of the workspace.
But the critical distinction here, and the paper emphasizes this, is that this is not just a cosmetic 3D shell.
Right. It's not just a picture. It's a behavioral physics model.
What actually behaves like the real thing.
Exactly. If a digital pipe in this twin is rated for 500 psi, the system knows the metallurgical limits of that pipe. If you pull a digital lever, the corresponding gears turn according to the actual laws of physics.
Wow, so it establishes a total baseline reality of the workspace.
Yes, exactly.
So once you have this highly accurate physics-bound 3D world, how does the human worker actually interact with it? Like while they're covered in grease on the factory floor.
Right. You need a bridge between the physical and the digital. And that's their second breakthrough, which they call field IQ.
Field IQ. Okay, so this is the hardware layer.
Exactly. It's the hardware and spatial computing layer. The worker wears smart glasses equipped with depth sensors and cameras. And this system uses something called SLAM simultaneous localization and mapping to anchor the digital twin perfectly over the physical machinery in the worker's field of view.
So it literally projects interactive, step-by-step guidance directly onto the real machine.
Yes. Two-way guidance right at the point of work.
That's incredible. But the real magic happens in reverse, doesn't it? Like, while the glasses are projecting instructions out to the worker, they're also pulling data back in.
Exactly. And that is breakthrough number 3. Assess-EU.
SSAQ, right.
It isn't just recording a flat video of what the worker is doing. It's utilizing spatial computing to track the actual skeletal movement of the worker.
Wait, it's tracking their bones.
Yes. It maps their hand joints, the trajectory of their tools, the speed of their movements, the exact angles they're using, all mapped against that 3D physics engine in real time.
So the value of SSEQ is that it captures the full context of the action. It doesn't just log a text entry saying task complete.
Right. It logs the geometric path the worker took to complete the task.
Meaning that tacit knowledge we talked about, that subtle flick of the wrist, or the specific way a master mechanic positions their body for leverage, it's mathematically captured in 3D space.
Exactly. Grounded in space and geometry.
Okay, here's where it gets really interesting. And let me throw a scenario at you that came to mind while I was reading this.
Yeah, go for it.
Let's say A junior tech is wearing these glasses, following the standard procedure to replace a component. But then a 30-year veteran master mechanic puts them on, and they completely ignore the standard procedure.
Happens all the time.
Right. They bypass some stuck mechanism using a highly unconventional, undocumented technique they invented a decade ago. It works perfectly, but it's totally off script.
Yeah.
What does the system do with that rogue data?
That scenario is the entire foundation of the fourth breakthrough. EON calls it verdict, or compound IQ.
The adjudication engine.
Exactly. It's the judge. When a SEQ captures a deviation from the standard procedure, verdict takes that new spatial data and adversarially verifies it.
Adversarially, like it fights the data.
Basically, it runs a new motion through thousands of stress tests within the Genesis 3D physics engine. It checks structural tolerances, fluid dynamics, safety protocols.
Okay, it's like playing a sports video game, right? But if you invent a brand new, highly effective play in your living room, the game's physics engine actually judges it, verifies it, and then instantly updates the game so every other player in the world can learn your move.
That is exactly it. It's essentially a high-fidelity flight simulator for industrial processes.
Wow.
If a pilot in a networked flight simulator invents a completely unprecedented maneuver to pull a 747 out of a stall, the physics engine mathematically verifies the aerodynamic.
Right. It confirms the wings won't rip off under the G-force.
Exactly. And once it verifies the maneuver is physically sound and superior, it updates the core software so every other flight simulator on the planet can teach that new maneuver.
So the system compounds the intelligence.
Precisely. If the veteran's shortcut passes that adversarial verification, verdict updates the gold standard 3D twin.
So the veteran's physical intuition, which used to be locked entirely in their own muscle memory, becomes the new baseline procedure for the entire global enterprise instantly.
Instantly. And owning that entire closed loop, authoring the twin, guiding the work, capturing the spatial data, and verifying the new intelligence that is what elevates this into the unified category of work intelligence.
Having just one of those is the product, but having all four is the category.
Exactly.
But wait, a flight simulator is one thing, because a crash there just resets the software.
Sure.
But running this loop live in a chemical plant or on a high-voltage power grid, that introduces a massive risk profile. I mean, generic AI hallucinates constantly.
It really does.
A chatbot hallucinating a legal precedent is just a headache for a lawyer. But an AI hallucinating a pressure release procedure in a refinery, that's a catastrophic industrial explosion. How do they mathematically guarantee that this loop won't authorize a fatal shortcut?
And this raises an important question because EON draws a very hard line here between generic AI and enterprise-grade work intelligence.
Right, because generic AI might give you, what, 80% quality?
Yeah, the white paper outlines that generic AI often operates at around an 80% accuracy threshold, which is fine for drafting an email.
Right.
But high-stakes physical operations demand 100% deterministic accuracy. To achieve that, the verdict system is governed by very strict operating principles, the first of which is advice before authority.
Advice before authority, meaning the system is never granted assumed autonomy over a physical process.
Never. It acts purely as an advisor, suggesting the next step based on the data, but a human expert always remains the final decision maker.
So autonomy is earned, basically.
Exactly. Furthermore, they establish a rigid standard of measurement, because you can't accurately measure a deviation if you lack a perfect theoretical baseline.
And that baseline is the Genesis 3D twin.
Right. It acts as the absolute specification. A SEQ is simply measuring the real-world delta, the millimeter by millimeter difference between the perfect theoretical model and the messy physical execution.
But if it's giving advice and measuring deltas on critical infrastructure, there has to be an airtight record of who made what call. Like, if a valve fails and a facility goes offline, the company can't just shrug and point at a black box algorithm.
Exactly. Which is why the system utilizes the XAPI standard to create an immutable audit trail.
XAPI.
Yeah, the Experience API. It's a data protocol that structures information organically, usually as actor, verb, object, and context.
Okay, so how does that look in this system?
Well, it translates spatial telemetry into a granular mechanical audit trail. It logs that operator John Doe applied 50 foot-pounds of torque to valve 4, received an overpressure warning from the spatial overlay, and manually overrode the warning at 14 bounds/hours.
Wow. So every suggestion the AI makes and every subsequent human decision is perfectly traced and accountable?
Every single one.
But, that level of granular tracking brings up a massive issue for me regarding data ownership.
Oh, for sure.
Because if I am that veteran master mechanic and I put on these glasses, the system is extracting my life's work. It's analyzing my muscle memory
Hmm.
and mathematically mapping my hard-earned tacit knowledge.
Yep.
So who actually owns that data?
Mm.
Am I just acting as an unpaid data labeling farm for a vendor's massive AI model?
Yeah.
Like, is EON absorbing my proprietary workflows just to sell a smarter foundational model to my direct competitors?
And given the current battles we are seeing with foundational models scraping the internet for data, this is a very pressing concern.
Absolutely.
But EON addresses this by architecting work intelligence on a fundamentally different paradigm. A core principle here is that the operator, the enterprise utilizing the system, owns the competence.
Oh, okay.
It's a compounding, strategic data asset that remains entirely behind their own firewall. EON provides the spatial computing engine and the verification architecture, but the specific weights, biases, and proprietary workflows extracted from the workforce belong exclusively to the enterprise.
Okay, so the knowledge stays in-house. Like a specific automotive manufacturer's highly optimized way of assembling a chassis remains their heavily guarded trade secret. They just now have a way to perfectly document it.
Exactly. And when you look at who actually benefits from this closed loop on the floor, the immediate application is what EON calls Human 2.0.
Human 2.0. So
Sure.
it's about the people first.
Right. The objective is not to build a system that replaces the master craftsman, but to multiply them.
Oh, I see. Because by capturing that spatial intelligence, it's like placing the company's smartest, most experienced veteran looking over the shoulder of every single junior worker.
Exactly. It dramatically accelerates the time to competency for new hires and elevates the baseline safety of the whole workforce.
But that individual augmentation rolls up into a massive shift for the enterprise balance sheet, too. I noticed Mats Johansson, the president of EON AI Ventures, makes a really fascinating point in the release.
Yes, what does he say?
He says CIOs tell us the same thing everywhere. The skills walking out the door are their biggest unmanaged risk.
Oh, it absolutely is. If your entire production line relies on 3 guys who are retiring next year, your stock price is incredibly vulnerable.
Right. So work intelligence takes that terrifying, unmanaged risk and converts it into a managed, owned, compounding digital asset. It finally takes its place right next to the ERP and the CRM systems.
It does. But, there is an even longer game being played here.
Oh.
Beyond the immediate augmentation of the human workforce, work intelligence is silently laying the foundation for what they call physical AI.
Physical AI, meaning robot.
Exactly.
Yeah.
We are rapidly approaching the era of advanced humanoid robotics. But when a piece of sophisticated robotic hardware arrives at a factory, it lacks the software to perform tactile, complex work.
Because, like we said earlier, you cannot train a robot to repair a turbine by feeding it Wikipedia articles.
Exactly, because there is no public, perfectly mapped, mathematically verified data set of complex physical labor.
Nobody has ever uploaded the 3D geometry of how much pressure to apply to a stripped bolt on a 1998 industrial pump.
Precisely. The work intelligence loop solves this data drought. Because every single time a human worker utilizes this system to perform a task, the closed loop is silently building a flawless, geometrically grounded data set of physical action.
Wow, so it's literally writing the curriculum for tomorrow's automated workforce.
Yes, the enterprise gets the immediate ROI of a smarter, safer human workforce today, while simultaneously banking the exact proprietary training data required to program their robotic fleets in the next decade.
That is wild. So what does this all mean when you step back and look at the entire architecture?
Well, Dan Lajuskar, the chairman of EON AI Ventures, synthesizes the historical context perfectly.
Yeah.
He points out that for decades, we've digitized everything except the thing that actually runs the business.
Right.
Because the technology simply wasn't there. Building accurate 3D simulators was prohibitively expensive. Lightweight smart glasses capable of complex spatial computing didn't exist. And legacy AI couldn't parse the world in 3 dimensions.
But now all of those barriers are gone.
Exactly. The demographic crisis of the Great Crew Change has perfectly intersected with the exact technological moment where all of these barriers have vanished simultaneously.
It is a profound convergence.
Hmm.
Work intelligence is fundamentally about capturing what was previously uncapturable.
Yeah.
It takes the fleeting, ephemeral physical intuition of human labor and anchors it into a permanent, verifiable digital reality. And that just compounds in value every single day.
It really does.
So as you go through the rest of your day today, listening to this, I want you to pay attention to your own physical environment.
Yeah, that's a good exercise.
Just think about the unspoken, unwritten physical instincts you rely on constantly. Like the way you know exactly how hard to push your front door so it latches without slamming.
Right, or the specific way you navigate your kitchen, reaching for a knife without even looking because your brain has spatially mapped the room.
Exactly. We all possess this vast internal reservoir of tacit knowledge, and we are finally crossing a threshold where software can map the complex geometry of that human instinct, preserving the physical genius of the workforce before it disappears forever.
The engineering behind this is truly remarkable, but, it leaves us with a lingering, almost philosophical question regarding the future of labor.
Oh, what's that?
Well, if our uniquely human tacit knowledge, that physical intuition, the subtle judgments, the tactile feel, honed over decades of sweat and experience, if all of that can now be perfectly digitized, verified, and ultimately utilized as the curriculum for autonomous robotics, what is the ultimate role of the human master craftsman in the future?
Oh, wow.
Right, like do we inevitably reach a horizon where humans only exist within the loop to invent the rare, creative edge case solutions that machines haven't seen yet? Or does a platform like this strip away the mundane repetition, elevating human potential and physical artistry to entirely new, unforeseen heights?